Hello everyone, I'm Lucas. So this will be my session B approach to 2025 May paper 2 AAHL paper. This is for the times of Asia and Australia as well. So let's go through session B. I found this paper like more tedious than like difficult. Okay, so let's see. Number 10. So this is an essay question. So let's see. This is look like a sequence question for me. So rectangular playing cards, and then they ask you about what's the number card of row number 3, right? So basically one count how many cards in here. So there's like 1, 2, 1, 2, 3, 4, 5, 6, 7. So I just write here. So there's 2. This will be 1, 2, 3, 4, 5, 6, 7, right? 7. The next one will be just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 of them. 15. Find T4. Okay, so I'll just write it out in here. So 2, 7, 15. The next one would be so plus 5 plus like 8, right? So this is like plus 3, I think. So plus 3. So 4 row, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so this is like how much? 11, right? Okay, so it's actually what we call a quadratic sequence here. Show that Tn equals this. So, wow. Okay. This is a quadratic sequence. All right, this is in your prior learning. So, in IB, actually the only 2 sequence types that we learn is arithmetic and geometric, but this is neither of them. This is a quadratic sequence, which is like an squared plus bn plus c. Okay, so some of school, if you took IGCSE like the Cambridge one, I think you know how to do it. So what you do is there's like a lot of ways. What you can do is just plug in 1 into here, and then make it as, let's say like this. Maybe we put 1, right? A plus b plus c. This will equals to 2, and then if we put 2, then will be like 4a plus 2b plus c. This will be 7, because like if we put 1, it'll be the first term. Put 2, it'll be the second term. So the third term will be put 3, which is 9a plus 3b plus c. This will be 15. And then you need to solve the triple simultaneous equation for a, b, and c. Okay, so we can use this. Okay, so let me try. So add an equation. So let me try to reset it. And an equation, so x, y, z, right? So it's like 4, sorry, it's like 1, 1, 1, right? So 1, 1, 1 equals to 2. And then this will be 4, 2 equals to 7. The last one would be 9, 3, oh, sorry, 9, 3 equals to 15. So A would be 3 halves, B would be 1 half, and C would be 0. So we apply it, it'll be like 3 over 2n squared plus 1 half of n. Okay, so it's exactly the same, right? So just copy it. Okay, so done already. So part C, I think, is like kind of not fair, I think. Okay, but like this is a quadratic sequence, so therefore recognize the sequence type, and then you need to sub in numbers and brute force it. So 3 marks. Okay, interesting. This is a really, if you cannot do that, you can do it. Just skip this and do the rest first, and then come back. There are 52 cards like playing cards. A complete pyramid stack. It's taken from 14 full packs. 5 maximum number of rows, right? So I think what we do is just put Tn equals to 14 times 52. Okay, so it'll be n times 3, n plus 1. Okay, use GC here. So graph x times 2, and then make this equals to 14 times 52. $21.86. So meaning you can create like you can like make 21 rows and a bit more. So therefore the only thing is like 21 rows. Okay. Okay, so done already. So E. A complete pyramid stack is using playing cards from a full pack with no cards left over. Right, so basically you need to fully use all the pack, right? Find the minimum number of rows in the stack. Okay, so I think this is a trial and error, to be honest. So what you do is just go to here, use the same equation, but this time you just keep on trial and error. So say 1. The intersection is like how much? Like 5 point something, right? So no. Then the next one would be 2. And then let's look at the intersection again. I think it's no, right? Because like it's a decimal. 8 point something, so no. And then 3. Okay, I think this is kind of stupid. So 8. Oh, it's 10 point something, so no. So 4. Okay, hopefully with enough time you can still get it. So 4, sorry, 7, 4. Okay, so 4. 11.6, so no. So the next one will be 5. Hopefully it's less than 10. 8, it's 5, right? Is it 5? Yes, 5. So 5 is the answer for 5 packs. Which is like how many? 260. Okay, so 260 cards. Okay, so that's just a trial and error game. So done already. So 5 packs is the answer. Okay, so a long edge with a playing card measure 88 mm. And an illustrative diagram. Find the minimum of number of cards needed to create a complete stack with a height more than 2 meters. So 2 meters, right? So let's say if a card box looks like this, right? So this is like 88 mm. So maybe make it bigger. So 88 mm. So let's try to find the height first. The height is important, okay? Because when you find like a tower that's like more than 2 meters, right? So we go to the top. So what's the angle? Oh, 60, right? So this is 60. So find the height first. So the height is sine 60 equals to h over 88. Okay, so this is a degree. Make sure you change it back to degree first. Or else the whole thing will be dead. Okay, so h would be like 88 times sine 60. Okay, 76.21 basically. So the 76.21 mm. So I want 2 meters, right? So how many of that, right? So basically imagine this is 2 meters. So 2 meters is like how many mm? So 2 times 100 to get the cm, and then times 10 to get the mm, right? So 2000 mm. Okay, I think like 1 cm should be like 10 mm, right? Okay, and then we want to find how many 7.76.21 first. Okay, can you put inside? Okay, so you need to put how many inside. So 2000 divided by this ugly thing, 26.2. So we're gonna put 26.24 as n, right? So 26 row basically. So how many minimum number of cards, right? So at least like 26 row. So how many cards? So 126. So at least. So 26 point something. So I need 27 basically. I need 27 rows in order to be more than 2 meters, right? Because this is just 26.24. This is like 26.24. If I want to get like taller than this one, then I need 27 rows, right? So I need 27. So we put 27 into the value on the top. So put 27 in here. So T27. This is like 27. 3 times 27 plus 1. Sorry, plus 1 over 2. Okay, so let's look at how many cards first. Actually, I think we're gonna use this one. Just delete this. I'll just calculate 27 rows in here. 1107. So I need 1107 cards. So what's the question here? Minimum of cards, right? So 1107 cards. Okay, so done already. So 5 marks. Okay. This is just a more of an IQ question. Okay, hopefully this is correct. Okay, so next one is the AAHL problem because like it's a probability density. The last one is a function with integration, I think. So let's see. So we got a probability distribution here. So marathon race, T is the time, and no runner complete less than 2.25. So basically, and no runner more than 7.5. So it's only existing between these two boundaries here. So what did they want? Find the value of, so they gave you here. Find the value of the integral, right? Okay, pretty easy. So make sure you change it back to radian whenever you're doing like integration stuff, or else the whole thing will be wrong. So I think that I'm pretty sure that some student would forget to change the radian. So we want to integrate this part, right? So 2.25 to 4.5, which is only existing on this graph. So we just type the whole thing in. Make sure you type it correctly. So 1 minus cos bracket 4 pi divided by 9, and then bracket x minus 2.25. Okay, so see where the graph is the same as what they gave you. So 2.25, hopefully this is 2.25. Alright, good. And then this is 4.5, right? Alright, perfect. So and then we want to find integration here. And then 4.5. Okay, so enter 0.42 something. So I think this is kind of stupid. So 0.4285, so 429, something like that. Write the mode of t. Mode, right? Remember, it's like the maximum. So therefore, the mode obviously will be 4.5. Determine which is greatest, the mode or the median. So obviously, it's the median is greater. So median is greater. Okay, because it's greater. You can write that median is greater than 4.5, obviously, because like remember for median definition of a continuous is when it's integrate up until when it's just like 0.5, right? But since when you integrate up until here, it's only 0.429, meaning that the median must be somewhere here in order for this to be 0.5. Okay, like the perfect middle. So this is like the logic behind. So because median is greater than 0.5, because like the integral of 2.25 4.5 of ft, it's smaller than 0.5, means the median is greater than 4.5. Okay, so like the mode. So I think you just need to write something like this. That will be okay. Okay, so part A is just a concept question. Okay, part B. So the runner who finished the race in 3.5 hours or less are considered to be fast. And then, of course, the final probability that it's considered to be a fast runner, right? So 3.5 hour or less. So it's just integrate 2.25 all the way to 3.5. Okay, so of ft. Pretty easy, so just go to your GC again. So 2.25, sorry, integrate 2.25, upper bound 3.5, 0.104. Okay, 0.104. So just the first part. Okay, it's 2 marks. Easy. The next one, find probability the fast runner chose at random finish the race in 3 hours or less. Okay, so this is a conditional probability because we know that it's like selecting from fast runner, right? And we want to know how many of the fast runners less than 3 hours. So find a probability that a fast runner chosen at random finishes the race in 3 hours or less. Wait, find a probability that a fast runner chosen at random finish at 3 hours or less. Okay, so I think it's just the probability. So conditional, right? Find the probability of first runner chosen at random finish at 3 hours less. So we want t less than 3, given that it's a fast runner already. Okay, so given that it's like less than t, it's less than 3.5 already. Okay, so if we apply it, the formula is like both of them and at the same time, so t less than 3 over probability of t less than 3.5. Okay, so we type it out in our calc, same thing. So t less than 5, I think we need to calculate that. So 2.25 and then 3. Okay, so 0.0247. And then 3.5, I think we got that. So it's just 0.104, right? Should you see the whole thing? 0.0247 divided by 0.104. 0.2375. 238, basically. Okay, so C is done. D. Find lower quartile of T. So lower quartile is pretty easy. Just like 2.25 integrate up until the lower quartile Q1. And this should be of ft, it will be 0.25. Okay, this is the definition of lower quartile. I think, can we use solver to use this? Let's try. Can I never use this as well? So calculus. Yeah, I think we can use it. So this one. So it's 2.25. Sorry. Let me change it back to here. 2.25, and this is x. And the ft, right? ft is the thing on the top. So 4 divided by 21, bracket 1 minus cosine, 4 pi over 9, and then bracket x minus 2.25, and then just equal to 0.25. Syntax error. Are we going to integrate this myself? How many marks? This one, 3, right? 0.25. Let me see. Is it like the reason here? Syntax error. Okay, so that probably I need to integrate this myself. So let's try. Okay, so because like my calc cannot integrate it, so for some reason, so let's say if this happened in your exam, I'll just integrate this myself. So I'll just integrate directly from the question. So I'll just copy in here. So this is the thing that I want to integrate, right? So 4 over 21 still stays 1 minus cosine. So when integrated 1, it's x. Integrated cosine, it will be sine, but since it's negative sine, and then 4 pi over 9 x minus 2.25, and then we're going to divide this by chain rule of inside, 4 pi over 9, so 2.25 and q1. Normally I think you use your calc to use solve the integration unknown. Okay, but I don't know why my calc doesn't work, so therefore I just leave it. So all you need to do is just plug in q1 inside, so 4 over 21 times q1 minus sine 4 pi over 9 q1 minus 2.25 over 4 pi over 9, and I want to subtract, put 2.25 inside, so it will put 2.25, then this will be 4 over 21 2.25 minus sine. Okay, this is like a long question to write. Well, basically this is 0, right? Okay, so actually you can just like do whatever that you like. 0.25. Okay. So what we need to do is just like try to solve this. So remember this, you don't really need to type at all because like 2.25 minus 2.25 is gone, right? So you just need to type this and this equals to 0.25. Okay, so what we need to do, just go to here. Okay, so I'm going to change this one to be sine because I'm lazy, sine. Okay, and then the 1 becomes a x because I treat it as q1, and then so many brackets. Let me delete some of them. Okay, so delete one more, 2 more brackets. Okay, and then I'm going to divide this by 4 pi over 9. Okay, so this is my first equation, minus 4 over 21 times 2.25. Oh shit, sorry. 2.25 should be in the outside. Okay, so enter, and then this equals 0.25. Okay, 4 point something. So Q1 4.01. Okay, so actually, do it by hand doesn't really worth like 3 marks. Okay, but it's okay as long as you got the answer, should be all good. Okay, so the next one, part E. Part E will be 5 marker. So each runner's time is converted to score by calculating as A minus BT, where T is time and hour and B are just constant bigger than 0. Consider random variable P represent a score, right? So we know that P equals to A minus BT because like this is the score, right? It's given that EP, it's 100, and the maximum possible score is 150. So use ET, it's 4.723, determine A and B, and value of B. Give an answer to nearest integers. Okay, so I think this is like a probability question now, right? So I'll just take the expected value of both sides. So we EP both sides. Then it'll be EA minus BT. Okay, so then this would be just A minus B expected T. Okay, so just remember expected value of a number is just a number. It's just the variable that's being expected value. So EP is 100, right? So 100. Okay, and A we don't know. B is B. ET it's 4.723. Okay, so I need one more equation. Maximum possible score, it's 150. Oh, I think the maximum possible score, right? Then P minus BT, the largest one should be 150. So what's the fastest for T again? Oh, no runners less than 2.25, right? Meaning that T equals to 2.25 is like the maximum score. So P should be 150 in the sense. Okay, so we know that if we plug it in, then it will be 150 equals to A minus B times 2.25. Okay, and then we'll solve the simultaneous equation in here as well. Okay, so use your calculator again. So add an equation. Okay, let me delete the whole thing first. Okay, so add an equation. So for here, just type the first one in. So just type X as A and then B as negative, like the B as Y. So 9 is 4.723. And this should equal to 100. And add another equation, same thing. So A, it's A. So A would be 1, B would be minus 2.25, and this would be 150. Okay, make sure I type it correctly. So A would be 195, B would be 20.2. Okay, so yeah. Part F. Also given that the variance is this one, find variance of P. Alright, so we just take a variance of both sides. So variance of P would equals to variance of A minus BT. So just remember variance, right? First of all, variance, you can like split it first. You can do it this way. So split it first. And then one thing to remind all of you is the variance of a number, it's always 0 because a number is well defined, doesn't have any variance inside. So variance of P would equal, so hope you still remember in the formal booklet, any variance of a constant times your variable could be brought outside but being squared. So this is your formal booklet. Please make sure that you revert to it. Okay, so look like this. So variance of T, it's 0.906. So B, I think we got it already. 20.2, right? 0.906. Okay, so calculator. So 3 9, so 369.68, so around like 370. Okay, so done already. That will be the variance of this question. So 2 marks and 5 marks. This question is kind of annoying, but not really that hard. The last question of the paper. Okay, let me make a new page. Okay, let's see. So consider a family function given by this. So it's a summation, right? Show that it's an even function. So I just copy this first. R equals to 0 all the way to n of -2 x squared r. Okay, so what do we want to do? Prove it's an even function. Okay, so this is kind of stupid, so just consider f of fn -x. But one thing kind of interesting is that paper 1 last question is also fn, paper 2 last question is also fn. Okay, so just some funny observation that I got in here. So which is integral of the sigma notation of -2 x squared part of r. So just remember that a negative square is a positive by nature, so -2 x squared r, which is fnx. So therefore fnx is even. Okay, I think just like 2 markers for this one, or 3 markers. Okay, so yeah. Part B. Show the f3 is this one, right? So I think we'll just put 3 inside. Okay, so f3. So since we're starting from 0 all the way to 3, then there's like 0, 1, 2, 3, right? We should have 4 terms. So if we put 0, then it'll be just 1, right? And then plus put 1 into here. Put 1 in here, then this will becomes -2 and then x squared. Sorry, I should be putting it here, my bad. Okay, so -2 and then x squared, and then put 2, that will be -2 x squared, and put 3, it will be -2 x squared 3. So it will be something like this. 2 power 3, that's an 8. Okay, so see where it's the same. Yeah, I think that's the same. So write down a similar expression of f4. Okay, similar expression, right? So obviously we're going to copy this. So 1 -2 x squared plus 4, and then minus x6, right? So times 2, that will becomes 816, and then x power 8, I think. Okay, just put 4 on the top. Okay, so put 4, yeah, should be this one. So it's like alternating, and then the square, like the power of x, add 2 every time, and the number becomes times 2 at the front. So C. Okay, so pretty easy, first one. Consider a function of this, and it's defined over a domain of here, where k it's bigger than 0. Find the possible values of k. So what's k here? Okay, it's like a domain of x, right? Okay, here's the part that a lot of like AAHL might forget. So if we look at here by itself, if we look at here, or actually look at here, this is a geometric sequence. I don't know where you recognize it, like times 2x squared negative times 2x squared negative. So therefore, this is a sum of gx. Okay, so since the question is asking you about like from r is 0 to infinity, right? Because like they want you to know like limits as n tends to infinity. So therefore, the condition of that it's sum to infinity. Okay, so sum to infinity is like u1 over 1 minus r, right? But since they're asking about a condition where it's like the x of the possible domain, it's defined, right? So meaning it's actually converging to a number, then you need to tell them that the ratio must be smaller than 1. It's in your formal booklet. So ratio in here, it's like -2x squared. Okay, so we want to solve this. So just use GEC. So delete everything, and then absolute of -2x squared, and then make this smaller than 1. So equals 1 first. Okay, so then make it more clean. So it's like I want this to be smaller than 1, right? So it's anything x less than 0.707 or √2. Wait, never mind. I think they want us to write as exact form. So then what we can do is write it back like this. So negative and the modulus, you can just ignore it because like you know that this is always positive, right? So like this. negative 1. Okay, so this is like the another way of writing it. This is also in your textbook as well, so please make sure you know how to read it. And then divide 2 to both sides. Like this, right? And then square root both sides. But when you square root both sides, right? So say square root this one and square root this one. To be very honest, this doesn't have any equation, like any solution, right? So it's just x squared less than 1 over 2. So when you root both sides, then x will be between 1 over root 2 and negative 1 over root 2. Okay, actually, you can look at it here. So this is like 0.707, right? So we look at here, like 1 over root 2. It's also the same number, so you know that it's like 1 over root 2 directly. Okay, so this is something that you need to know. So that's basically it. So C1 is done. C2. Express f(x) as a rational function. So obviously this is sum to infinity already. Okay, so a and b are to be determined. Okay, so all we need to do is just use the sum to infinity formula. So s infinity, u1 over 1 minus r. The f and x could be written as u1, which is 1 over 1 minus r. The ratio is negative 2x squared. Okay, so 1 over 1 plus 2x squared. Okay, so yeah, that's basically it. So let's see, a and b are constant to be determined, right? So a will be 1, b will be 2, but you actually don't really need to write that. Okay, so that's 5 marks already. So D. The function g is defined by gx equals fx for a domain 0 to k. So now they're restricted only to the positive side. Justify that g inverse exists. Okay. I think it's like 6 marks, right? Okay, what we strongly recommend you to do is actually just draw it out. Okay, so draw the whole graph out. So draw the gx out first. 0 to k, right? K, it's like 1 over root 2. So 1 over 1 plus 2x squared. Okay, so it looks something like this. But since we're restricted only to the right-hand side, right? So the x will becomes 0 and 1 over root 2. So let's see the graph. Okay, so it looks like this. I think you just need to draw it to them. Like this, right? Something like that. So since the question asks you why is it like exists, right? So all you need to tell them that for x between 0 and 1 over root 2, f and x is strictly decreasing. So actually I would recommend you prove this for them as well. So try to differentiate this once, because it's like so many marks, right? Therefore I don't want to risk it. So when you differentiate it, differentiate this, right? So don't use quotient root. So we'll move this to the top by negative. So negative 1 plus 2x squared minus 2, and then differentiate inside, which is 4x. Okay, and then all we need to do is just recognize that whenever you're using this domain, when x is positive, this will be positive, and this one is positive by nature. So therefore, this thing and this thing is positive. So therefore, f and this one, it's smaller than 0. So I'll actually recommend you prove it to them. So therefore, f and x is a 1-to-1 function, which implies inverse exists. Okay, so there's like I think a full a logic behind this in order to get a maximum number of marks. Okay, just draw a graph, but actually you need to describe a shape. So find g inverse. Okay, this is like pretty easy. So find inverse, right? So y equals to 1 over 1 plus 2x squared. Flip xy, so I got this one. Okay, and then flip both sides as a denominator. So I got 1 over x, and 2y squared equals to 1 over x minus 1. 2, so this is like divide everything by 2. 1 over 2x minus 1 over 2. root both sides. So so root, right? So root this ugly thing. So I think you take the positive value because like the whole thing in the graph here, both x and y, like both x and y are positive for both of them. So when you flip both x and y, right? This is actually your x value, but since it's like positive anyway, so therefore you stick the positive answer here. So no need negative. Okay, so G inverse. Okay, so that's the answer. And we want to state the domain, right? So remember the domain is the range of the original function. So we'll go to here. So we'll calculate the range of this function first. So this is like 1, right? And let's find 1 over root 2. 0.5. So this is like 0.5. So we know that the range will be between, do we allow equal? Oh, we don't really allow equal in the right hand side. So we don't allow the right hand side. So it will be between the range, right? So 0.5. Alright, so basically this is actually a hollow circle. We don't allow this point. Okay, so we don't allow the 0.5. So let me try again. So it'll be between 0.5 and but allow 1. Because in the question in here, we don't really allow equals to k, right? So we don't allow this point. So this is actually a hollow circle point. So we don't really allow this point, but we allow this point. Okay, so it's like anything between 1 and 0.5, but doesn't include 0.5. Okay, so yeah. So let's look at the last question. So 6 minus 3. Hope this question is actually hard. Because like up until this point, I think this question is still pretty simple. So region R is enclosed by G and G inverse one area of R. So okay, just remember that inverse, it's always mirrored on y equals x, right? So what you can do in here is just find this area first and times that by 2 to get the other side. So let's try to find this intersection first. Okay, so we go to the graph originally in here and plot y equals x and then look for the intersection first. Okay, so the intersection it's 0.595897545. Okay, for both of them. Okay, 5897545. Okay, so let's try to find this particular area. So name that's 1. Okay, so the area will be 0 all the way to 0.595897545 of the top curve minus the bottom curve. So the gx, which is the thing that we got in here, 1 over 1 plus 2x squared minus x dx. So same thing, you don't need to integrate yourself, just you should calculate to help you. So calculus and then 0. Oh my god. 0.5897545. 1 over 1 plus 2x squared minus x. So let me make sure that I didn't type wrong. Okay, so 0.3176. And then the area, right, will be just this times 2 because like top and bottom are the same anyway. Okay, that will be my best answer here. So to be honest, I think this is pretty easy. Okay, the last question is like this is the only part that might be difficult, but like to be honest, I think the last question is like easier than paper 1. Okay, so any regards about this paper, I think this, to be honest, paper 2 take more time than paper 1 because some problem with the calculator in here. Okay, so I think it's harder than paper 1 in my opinion because like it's not normal. Okay, let's say tangent, really rare they put a tangent graph in here. Okay, and like section B is hard. I think section B is, I think the sequence is actually hard. This is not hard. This is like pretty easy, but E and F might be difficult because like some of AA students, they might forget that they will be tested on this type of stuff. Okay, because like this is more in the AAHL syllabus. The last question, if you don't recognize it as a geometric sequence, then basically the whole thing you're dead. Okay, but the last question is not hard at all. So this is my best approach. In terms of difficulty, difficulty level, I think this paper is maybe 6 out of 10. I think it's easier, but it's like more like annoying. Okay, so thank you very much for watching this video. So have a good day. Bye bye.